Now that we have discussed different types of vectors, let's talk about the algebraic operations on vectors. We'll discuss two operations on vectors, that is addition and subtraction. Okay, now we'll look into the very important part, which is the vector addition. See, when we talk about the vector addition, there are two laws, or you can say there are two ways in which we can do the addition of vectors, which you guys already know. The first one is the triangle law, second one is the parallelogram law. Okay, now in triangle law, suppose say you have two vectors, say this is OA, and say you have some other vector here, which is some vector. Let's assume that this is B, say this is vector A. Now what we do is we take equal vector. Remember, equal vectors are what? Same magnitude as well as same direction, isn't it? So here we'll take, you have that vector B. Let's go, we are going to take the same magnitude and same direction here. Let's call this as B. Now that you have OA and you have AB vector, now what we do is we'll join OB. So OB becomes the resultant. In the sense, in triangle law of addition, the vectors are taken as the sides of the triangle. Alright. So when you take it as the sides of the triangle, the sum of the two sides, which represents the vector, will give us the resultant in the opposite direction. That means we are not looking at this at a cyclic order. We are not looking at OA, AB and BO. We are not looking at BO. If you take OA, AB and BO, this becomes cyclic order, isn't it? So what we are doing, we are taking OA, AB and OB. We are taking OB. So here OB is equal to OA plus AB. The resultant R is equal to vector A plus vector B. This is basically the triangle law of addition, where we are going to take two vectors, where one vector ends, another vector starts. Clear? This is the situation where we are going to take the triangle law of addition. I hope this is clear. Okay, now if you take the vectors in the cyclic order in this triangle of addition, that means if you take OA plus AB plus BO, this becomes a zero vector, because OA, this is going to be A, this is going to be B, the next one is the negative of OB, correct? Which is negative of A plus B. Basically the entire thing cancels out, so you are going to get zero vector. Clear? So in triangle law, the first important point is the vectors are not considered in the cyclic order. First point. Second point, whenever we talk about the addition of vectors, we take it along the sides of the triangle. Clear? So in this case, the resultant is the third side. So R is equal to vector A plus vector B. This is the triangle of addition. Now we'll look into the parallelogram law of addition. In parallelogram law, see, in the parallelogram law, parallelogram first we'll write. Okay, so we have one vector like this. Say this is OA, this is vector A, and we have another vector starting from the same point, this one. So say this is OB. Now the resultant of these two, this is going to be the diagonal of the parallelogram formed by these two. Now what we mean by that? So assume that we are going to take, so let's assume you are going to take something like this, and say you are going to take one more like this. Say this point is C. Now you have OA, OB are the two sides, and OACB, this is a parallelogram. The resultant is going to be OC like this. This is the resultant. That means if two vectors are co-initial vectors, very, very important, co-initial vectors, and these two vectors form the sides of the parallelogram, then the resultant is the diagonal of the parallelogram. This basically tells us the parallelogram law of addition. So here we have OC is equal to OA plus OB. So the resultant R is equal to vector A plus vector B. This is basically the parallelogram law of addition. Clear? Now, one major difference between parallelogram law and the triangle law. In parallelogram law, the vectors are co-initial vectors, whereas in triangle law, they are not co-initial vectors. Clear? This is the major difference between triangle and parallelogram law. So here, a lot of examples you can say. Lots of examples. Like if you look at carom, carom is where we have all played carom. So whenever you are playing a carom, you hit a pawn. Now in this case, suppose if you have a single pawn, then what happens? The first pawn goes, it hits, the second pawn will move, correct? This is an example for a triangle law. Assume that you have two pawns. Okay, so there are two pawns. Say you hit the pawn like this. These two pawns will go like this, correct? Now this is an example of parallelogram law of addition. So that particular game can explain both triangle law as well as parallelogram. Fair enough? Now there are two important properties of vector addition, commutative and associative. Okay, so we'll discuss these two quickly. The first property, which is the commutative property. Now vector addition is commutative in the sense vector A plus vector B is equal to vector B plus vector A. Clear? You can use parallelogram law in confirming this one. It's quite easy to understand. Think about it. See, this is vector A. So assume this is vector B. Now the resultant is going to be this, which is vector A plus vector B, isn't it? Now what we'll do, we'll take, see, we'll take this one, we'll take this one. This is vector A, this is vector B. Now with B and A also, the resultant is going to be the same. If you take the diagonal, you can also write this as vector B plus vector A, because both of them are sides of a parallelogram, isn't it? So A plus B is equal to B plus A. This is the first property, or you can say first property of vector addition. The second one is the associative property. Okay, second one is the associative property, which basically tells us that A plus B plus C is equal to A plus B plus C. This is basically the associative law of vector addition. So vector addition, it is applicable, or you can say that it satisfies both commutative as well as associative law. Clear? Now we'll look into the vector subtraction. How do we do vector subtraction? Now vector subtraction, see, in vector subtraction, what exactly we do is that assume that you have a vector like this. So say this is O, say this is A. Let's assume that this is vector A. Okay. Now let's say we have another vector, something like this. Say this is B. Say this is vector B. Now what we do? We change the direction, 180-degree shift, and then with the same magnitude, we'll write the vector. Okay. In the sense here, what we are doing, the same vector AB will change the direction by 180-degree, and with the same magnitude we'll write. Let's call this as B dash. So AB dash becomes minus vector B. AB is vector B. So AB dash becomes minus vector B. Now what we do? You join O and B dash here. See, according to the triangle law, OB dash is equal to OA plus a b dash. Correct? So the resultant R is equal to vector A plus of minus vector B. What is A plus of minus B? Minus, right? So what do you get now? Vector R is equal to vector A minus vector B. This is basically vector subtraction. See, whenever we talk about vector subtraction, we take vector addition itself. But then, especially in triangle law, you can do the same thing with parallelogram law also. What we do, we take the vector addition, but then we change the direction of one of the vectors, and then we add using the vector addition, which pretty much gives the same result. Clear? So these are the two major things, vector addition and vector subtraction. In the next video, we'll look into vector multiplication, which is a major thing in vector. Clear? We'll look into that in the next video.